All right, looking at the various types of attacks will help you to prepare for such an attack. And some of the attacks can be classified into categories, and some are, well, literally a class by themselves. I wanted to say that so much.
I know you did. We're going to start with a bandwidth attack, right? A bandwidth attack floods a network with a high volume of data packets to really overwhelm the network bandwidth to such an extent that it starts dropping packets. Now, do you think a single computer can generate so many requests?
I don't think so.
Probably not.
Yeah.
So DDoS attacks use several computers to flood a network. A DDoS attack floods a network routers and switches with huge amounts of traffic. Now, attackers typically use botnets to flood networks with ICMP echo packets. When a DDoS attack takes place, the whole bandwidth is more or less used up, and hardly any bandwidth will be left for legitimate use. The next type of attack is a server request flood attack. In this attack, an attacker sends really too many service requests, and the target is flooded with a very high number of connection requests. Attackers use zombie armies to set up and tear down TCP connections.
Sounds cool.
They use zombies to request for website homepage connections, such as the extent the site performance degrades.
Yeah, sounds cool, but it's really not.
No, it's
Zombie
really
armies
not
are
cool.
not a good thing. And SYN flooding attacks exploit the three-way handshake method. The client or the attacker sends a fake SYN request to the target server. The target server sends a SYN ACK to the faked client, thinking that it has received a legitimate SYN request from the faked client. Servers will not send SYN ACK to any client if it has not received a SYN packet first. Now, as you know, if a client is faked, the target server will think that a TCP SYN is initiated by the faked client and will respond to it instead of the real client that had initiated the TCP SYN to the target victim server. So the target server waits for the acknowledgement to confirm SYNAC has reached the fake client. The target keeps track of the partially open connection for about 75 seconds. The client or the attacker will continue to send multiple fake SYN requests to the target server, thereby filling the listening queue. And then when the queue is full, no new connections will be allowed, and a genuine user may not be able to establish a connection at all because it's full.
Yeah.
Now, this ability to fill the queue for 75 seconds at a time and making it unable to open another connection is considered a DOS attack.
That's right.
Now, there's one more thing, one more flooding attack that I want to talk about real quick. Let's look at Internet Control Message Protocol, or ICMP. Attackers send a large number of ICMP echo packets with fake source addresses to a target server. ICMP packets are then used for locating network equipment and determining the number of hops to get from the source to the eventual destination. Right. And these ICMP echo requests can clog the bandwidth. Now, after ICMP threshold is reached, the router rejects all the ICMP echo requests from all addresses in the same security zone for the remainder of the second one.
That's right. Now, here's another thing. Application-level denial of service attacks are an emerging class of attacks that is really, it's becoming more and more potent.
Yeah, it is, yeah.
Application-level denial of service attacks target higher layers in an application stack. These attacks are more efficient than TCP or UDP attacks, but these attacks require fewer network connections to achieve malicious purposes. So application-level DOS attacks essentially mimic flash crowds with the goal of severely crippling an electronic service. A flash crowd is a more generic term to describe a network host which suddenly receives a lot of traffic. These attacks evade traditional DOS filters by morphing the attack requests so that they are nearly indistinguishable from legitimate requests. Application layer attacks can affect many different applications. A lot of application-level flood attacks target the HTTP to exhaust the resources and limit web services.
Right, and so at this point, it's probably a smart thing to take a look at how peer computers that share resources with others are targeted. Now, peer-to-peer, P2P, computing or networking is a distributed application architecture that partitions tasks or workload between peers, peer-to-peer. Peers are equally privileged. equipotent participants in the application. Peers make a portion of their resources, such as processing power, disk storage, or network bandwidth, directly available to other network participants. Everybody's on the same field. Exactly. And they don't require central coordination by servers. Peers are both suppliers and consumers of resources. They share everything.
That's right.
Attackers have found a way to exploit a number of bugs in peer-to-peer servers to initiate DDoS attacks. Through these, attackers instruct clients of peer-to-peer file sharing hubs to disconnect from their network and connect to the victim's website. And as you can imagine, this will result in several thousand computers aggressively trying to connect to a victim's website, right? So a typical web server can handle a few hundred connections per second before performance obviously starts to go downhill and begins to degrade. Now, most web servers fail almost instantly under 5,000 or 6,000 connections per second. So you can imagine the damage that can be done here.
Right. I mean, they're not really built to have that much going on.
They can't handle the traffic.
Right. Now, so far we've talked about flooding requests and thereby crippling the system. Now, let's look at permanent denial of service attacks, right? This is also called flashing. And the attacker exploits security flaws or vulnerabilities in the remote administration on the management interface of the victim's hardware. Now, using these vulnerabilities, an attacker replaces a device's firmware with a modified or corrupted firmware image so that the device is unusable for its original purpose until it can be repaired or replaced. Now, this type of denial of service is a pure hardware-targeted attack, which can be much faster and requires fewer resources than using a botnet in a DDoS attack.
Right.
Now, zero-day attacks are unknown or new attacks which can exploit vulnerabilities since no patch is available. We don't even know about them yet.
That's right.
It's called zero-day attacks because the developer has 0 days to fix the flaw.
That's not a lot of time.
No.
So far, we have discussed denial of service, distributed denial of service, and the impact of these attacks and how they attack.
That's correct.
We also saw that botnets will be used in distributed denial of service.
Covered a lot.
A lot.